Good evening to you all. Hope that all are doing well. Since your board exam is nearing, all will be in a mood to learn all the subjects. Okay, so the topic which I got is definite integrals, something related to definite integrals. Actually, definite integrals, it will not trouble us much if we know the integration formula very well. That is very easy. But the beginning of it, instead of direct evaluation, we are evaluating definite integrals as the limit of a sum. That will be a little bit difficult for you. So here, we are going to discuss some problems related to that topic. And I have selected these problems from previous year's question bank conducted by various state boards. Hope that it will be helpful to you. Okay. Let's start with the formula. We know how to evaluate definite integral a to b f of x dx. Integral a to b f of x dx. What is a and b? Variable here is x. Independent variable is x. X is varying from a to b. So lower limit is a, upper limit is b. When direct integration, we know how to evaluate this. F of b, integral of us, we'll find integral of f of x. Then f of integral of f of x at the point b, that is upper bound, minus integral of f of x at the lower bound, x is equal to a. Now, how we are evaluating this as the limit of a sum? It is like this. Integral a to b, f of x dx is equal to b minus a, upper limit minus lower limit. Limit n tends to infinity, 1 by n, f of a plus f of a plus h plus f of a plus 2h plus etc. plus f of a plus n minus 1h. Now let's see what is this h. And a is the lower bound and h is b minus a by n. Now what happens? In this limit, we have the condition n tends to infinity. What happens when n tends to infinity? What will happen to this h? When n tends to infinity, we know that 1 by n will tend to 0. And since h is equal to b minus a by n, h will tend to 0 as n tends to infinity, right? Lakshmi ma'am, am I audible?
Yes, ma'am.
Okay. So I repeat the formula. Integral a to b f of x dx is equal to b minus a, limit n tends to infinity, 1 by n, f of a, and we know what is f of a. Value of the function f at x is equal to a, f of a plus h, value of the function at x equal to a plus h, plus f of a plus 2h plus etc. plus f of a plus n minus 1h. And what is h? b minus a by n. We can see that h will tend to 0 as n tends to infinity. Okay. Now moving on to problems. Evaluate the following definite integrals as the limit of a sum. First problem. Integral 0 to 1, 2x plus 3 dx. We'll start with the formula. What is the formula? We have integral a to b f of x dx is equal to b minus a, limit n tends to infinity, 1 by n, f of a plus f of a plus h plus f of a plus 2h plus etc. plus f of a plus n minus 1h. Now let's fix a and b. And what is a? A is the lower limit. So A is equal to 0 and B is the upper limit. B is equal to 1. A is equal to 0 and B is equal to 1. Now, what is H? H is equal to B minus A by N, and B is 1, A is 0. So it will be 1 minus 0 by N, which is 1 by N. So here H is equal to 1 by N. Now coming to the problem. Integral 0 to 1, 2x plus 3 dx is equal to, we can substitute for B and A. It will be 1 minus 0, limit n tends to infinity, 1 by n, f of A equal to 0. So f of 0 plus f of 0 plus h plus f of 0 plus 2h plus etc. plus f of 0 plus n minus 1 h. Now, no need to write 0 plus h, 0 plus 2h, etc. Instead, we can simply write it as f of h, f of 2h, f of n minus 1 h. So that is equal to 1, then limit 1 by n tends to infinity, 1 by n, f of 0 plus f of h plus f of 2h plus etc. plus f of n minus 1 h. Now let's find these values one by one. What is f of x? F of x here is 2x plus 3, right? F of x is 2x plus 3. Now we need f of h. So what is f of h? Sorry, first we need f of 0. I can see Lohit. Lohit, if you have any doubt, you can put it on the chat box.
Students, if you are having any doubts or if you want to communicate with ma'am, you can type in the chat box or in the Q&A. So we'll be giving you reply. I think ma'am, you can continue.
Okay.
If there is anything, students will type it.
Okay, okay. Now let's find f of 0. F of 0 is, f of x is 2x plus 3. And we know how to find f of 0. Replace x by 0. So 2 into 0 plus 3, that is 3. Now, coming to f of h. F of h will be, replace x by h. So 2h plus 3. Then what will be f of 2h? F of 2h will be 2 into 2h plus 3. That is 4h plus 3. Now, f of 3h. F of 3h is 2 into 3h plus 3. 6h plus 3. Similarly, proceeding like this, what can be f of n minus 1h? F of n minus 1h will be 2 into x, that is n minus 1h plus 3. So 2n minus 1h plus 3. Okay. Let me check any doubt in the chat box.
Students, if you have any doubts in the question, in the topics, you can type it in the chat box. We'll be discussing those in the session. Ma'am, you can continue the session. We can clarify.
No, ma'am, actually, I want to, that one student, madam, actually, we couldn't understand what you are blabber. Parvendan. Parvendan, what is your doubt? Can you please type your doubt here? Or shall we come to him after the session? Lakshmi ma'am, can you please check, am I audible to students?
Yes, ma'am, you are audible to students. I'm checking those student Parvindan. He is actually not in the attendees list.
Okay. Okay, then shall I move
We
on?
can continue. Yeah, we can continue.
Okay. So what we have done, we are finding the terms in this expression. The formula is integral a to b f of x dx is equal to b minus a limit n tends to infinity 1 by n f of a plus f of a plus h plus f of a plus 2h plus etc. plus f of a plus n minus 1h. We can see that a equal to 0, b equal to 1 from the question, and h is b minus a by n. So 1 minus 0 by n, h is equal to 1 by n. Now, in this formula, we have to replace a by 0 because in the question, upper bound, lower bound is 0. A is the lower bound is 0 here. And h is 1 by n, that we'll replace after completing the problem to avoid confusion. Then b minus a is 1 minus 0, limit n tends to infinity. F of a, that is f of 0, f of a plus h, 0 plus h, f of a plus 2h, f of 0 plus 2h plus etc. plus f of 0 plus n minus 1h, which is equal to limit n tends to infinity 1 by n f of 0, then 0 plus h is f of h. Similarly, f of 2h plus f of 3h plus etc. plus f of n minus 1h. Now, f of x is 2x plus 3. So f of 0 is 2 into 0 plus 3, 3. F of h is 2 into h plus 3, 2h plus 3. F of 2h is 2 into 2h plus 3, 4h plus 3. F of 3h is 2 into 3h plus 3, 6h plus 3. Similarly, proceeding like this, f of n minus 1h is equal to 2 into n minus 1h plus 3, which is equal to 2 into n minus 1h plus 3. 2n minus 1h plus 3. Okay. Now, coming to the problem. Integral 0 to 1, 2x plus 3 dx is equal to limit n tends to infinity 1 by n. Now we are substituting the values 1 by 1. F of 0 is 3 plus f of h is 2h plus 3 plus f of 2h is 4h plus 3 plus f of 3h is 6h plus 3 plus etc. plus f of n minus 1h, that is 2n minus 1h plus 3. Now we are going to group these terms. We can see that in each and every term, 3 is there. 3, then 2h, second term, 2h plus 3, fourth term, third term, 4h plus 3, fourth term, 6h plus 3, etc. The last term, that is nth term, 2 into n minus 1h plus 3. Next step, we are going to group all the 3's. How many 3's are there? There are total n terms, starting with f of a to f of a plus n minus 1h, total n terms. And we can see that each and every term 3 is present. And we are going to collect all the 3's. Then there will be n 3's. So 3 plus etc. plus 3 n times. Then what remains? Second term 2h is there plus third term 4h is there plus 4h plus 6h plus etc. The last term, that is in the nth term, 2 into n minus 1h. Okay. Again simplifying. Limit n tends to infinity 1 by n, 3 plus 3 n times 3n. Then in these terms, we can see that 2h is common. So I'm taking the 2h outside. Then what will we get? 2h, if you are taking 2h from here, it will be 1. Then from 2h, 4h, we are taking 2h outside, it will be 2. From 6h, we are taking 2h outside, it will be 3. Then in the last term, 2h, we are taking outside, it will be n minus 1. So this is equal to limit n tends to infinity, 1 by n, 3n plus 2h into 1 plus 2 plus 3 plus etc. plus n minus 1. And we know how to find this sum, 1 plus 2 plus 3 plus etc. plus n minus 1. Sum of first n minus 1 natural numbers. What is the sum of first n natural numbers? Sigma I equal to 1 to n, I equal to n into n plus 1 by 2. Here in the place of n, we have n minus 1. So if we are replacing this n by n minus 1, it will be n minus 1 into n by 2. Okay. So I'm going to replace this using that formula. This is equal to limit n tends to infinity, 1 by n, 3n plus 2h sigma I varies from 1 to n minus 1 I. That's equal to limit n tends to infinity, 1 by n, 3n plus 2h into n minus 1 by 2. And we know that h is equal to 1 by n. Now, how we can apply the limit? Limit n tends to infinity, 1 by n, 3n plus 2 into h. I'm replacing by 1 by n because h is equal to 1 by n here. So 2 into 1 by n minus 1 into n by 2. This 2 and 2 will get cancelled, n and n will get cancelled. So what remains is limit n tends to infinity, 1 by n, 3n, then 2 will go, n will go, n minus 1. Then 3n plus n is 4n, 4n minus 1. So limit n tends to infinity, 1 by n into 4n minus 1. When we divide it by, if we are multiplying by 1 by n, this will become 4, then 4 minus 1 by n. So limit n tends to infinity, 4 minus 1 by n. As n tends to infinity, 1 by n will tend to 0. So what is there is 4. Answer is 4. Lakshmi ma'am, shall we go for the doubt clearing session now? First, after the first problem?
Yes, ma'am. Yes, ma'am. N minus 1 part. The students are asking, can you please explain the n minus 1 part?
N minus 1 part.
That's the first question. It's by Pranav S.
Please explain the n minus 1 part. N minus 1 part means in the formula, Pranav. That is the formula. Then, or you mean the number of terms? Lakshmi ma'am?
Yes, ma'am.
Can you please give Pranav mic?
Okay, just give me a minute.
Yes.
Okay, that will be fine. So hi Pranav, now I have given you an option to speak, so you can just try speaking. You can unmute and talk now. We have given you the option. Yeah. Can you please be high in your voice? It's not audible actually.
Hello.
Hello,
yeah, fine.
Pranav.
Yeah, fine.
Good evening.
Good evening, Pranav. Can you make it a little bit louder? Hello.
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 Pranav. Okay.
Hello.
Your sound is feeble.
Some problem with the mic.
Okay, Pranav, what is your doubt?
That some of first n natural numbers, how it
Ah.
came in -1.
How it came in -1?
Yeah, I didn't hear properly.
This one. You're asking this one.
Yes.
Okay, Pranav. We have grouped the terms like this.
Okay.
There are total n terms, and every term 3 is present, right? First term is 3, second term 2h plus 3, third term 4h plus 3, etc. Nth term 2n-1h plus 3. In all these n terms, 3 is present. So there are n 3s. 3 plus 3 plus etc. plus 3 n times. Is it fine?
Yes, ma'am.
Okay, so that is 3n. Sum is 3n. Now another group is there. What is that group? 2h plus 4h plus 6h plus 2n-1h, right?
Yes.
Okay, that is clear.
Clear.
Now this 2h plus 4h plus 6h plus etc. plus 2n-1h, we can take 2h as common factor. Am I right?
Yes, we can.
Okay. So if you are taking 2h as common factor, then what will happen to these terms? First term will become 1, right?
Yes.
After taking 2h outside. And second term will become 2. This will become 3, right?
Okay.
Similarly, what will happen to the last term?
n-1.
n-1. So it is limit n tends to infinity, 1 by n, 3n plus 2h into 1 plus 2 plus 3 plus etc. plus n-1. Okay.
Okay.
Now we are starting with 1, 2, 3, etc. and ending in n-1. And we are taking the sum of all these integers, right?
Yes, ma'am.
That means here we are taking the sum of first n-1 natural numbers. Is it clear?
Clear.
Now, what is the formula for sum of first n natural numbers?
n into n plus 1 by
n into n plus 1 by 2. Here, instead of n, we have n-1, right?
Oh, okay.
So we have to replace this n by n-1. So it will be n-1 into n-1 plus 1. That is n, right?
Okay.
Okay. So n-1 into n by 2. Got it?
Got it. Thank you.
Okay. Shall we move?
Yes.
Any other doubt?
Okay.
Lakshmi. Okay. Thank you, Pranav. Lakshmi ma'am, shall I move on to the next problem?
Yes.
Okay. Okay. Next problem. Integral 0 to 5 x plus 1 dx. Starting with the formula. Integral a to b f of x dx is equal to b minus a, limit n tends to infinity, 1 by n, f of a plus h plus f of a plus 2h plus etc. plus f of a plus n minus 1h. Then we know that a is equal to 0. Lower bound is 0, upper bound is 5. So a equal to 0, b equal to 5, h equal to b minus a by n, 5 minus 0 by n, so 5 by n. Coming to the integral part. Integral 0 to 5 x plus 1 dx, b minus a, 5 minus 0, limit n tends to infinity, 1 by n, f of a, and a equal to 0 here. So f of 0 plus f of 0 plus h plus f of 0 plus 2h plus etc. plus f of 0 plus n minus 1h. 5 into limit n tends to infinity, 1 by n, f of 0 plus f of h plus f of 2h plus etc. plus f of n minus 1h. Now let's find the terms one by one. F of x is x plus 1. We need f of 0. F of 0 is 0 plus 1, that is 1. Now we need f of h. F of h will be x plus 1. X should be replaced by h, so h plus 1. Now f of 2h, replace x by 2h, it will be 2h plus 1. F of 3h, replace 2h by 3h, so 3h plus 1, etc. What will be the value of f of n minus 1h? F of n minus 1h is equal to n minus 1 into h plus 1. X should be replaced by n minus 1h. Now, we can substitute these values for finding the integral, evaluating the integral. Integral 0 to 5, x plus 1 dx is equal to 5 into limit n tends to infinity, 1 by n, f of 0, that is 1, plus f of h, h plus 1, f of 2h, 2h plus 1, f of 3h, 3h plus 1, etc. plus n minus 1 h plus 1. And we can say that 1 is present in each and every term. N terms are there. So 1 plus 1 plus 1 n times. What remains is h plus 2h plus 3h plus etc. plus n minus 1 into h. Exactly same as the previous problem. This is equal to 5 into limit n tends to infinity, 1 by n, 1 plus 1 plus 1, etc. plus 1 n times is n. Then in this, among these terms, we can take h outside. So h into 1 plus 2 plus 3 plus etc. plus n minus 1. That's equal to 5 into limit n tends to infinity, 1 by n, n plus h into 1 plus 2 plus 3 plus etc. plus n minus 1. 5 into limit n tends to infinity, 1 by n, n plus h into this also sum of first natural numbers from 1 to n minus 1. So sigma I varies from 1 to n minus 1 I. We know the value. Substitute the value there. 5 limit n tends to infinity, 1 by n, n plus h into this sum is n into n minus 1 by 2, h equal to 5 by n. In the next step, we know we have to replace this h by 5 by n. What will be the result? 5 into limit n tends to infinity, 1 by n, n plus h is replaced by 5 by n minus 1 into n by 2. 5 to 5 by 2, we cannot cancel, and n will get cancelled. Then what will be the simplified form? 5 into limit n tends to infinity, 1 by n, n into 5 by 2. Then this n and this n will get cancelled. 5 by 2 into n minus 1. Again simplifying. 5 into limit n tends to infinity, 1 by n, n plus 5 by 2n minus 5 by 2. Okay. Lim 5 into limit n tends to infinity, 1 by n. See here, n plus 5 by 2n. So n plus 5 by 2n, it will be 7 by 2n. So 7 by 2n minus 5 by 2. And if I am multiplying this by 1 by n, 7 by 2n into 1 by n, so 7 by 2, then 5 minus 5 by 2n. 5 minus 5 by 2 into 1 by n minus 5 by 2n. So 5 into limit n tends to infinity, 7 by 2 minus 5 by 2n. And we know that as n tends to infinity, this 1 by n will tend to 0. So this becomes 0. What remains is 7 by 2. 5 into 7 by 2, answer 35 by 2. Lakshmi ma'am?
Yes, ma'am.
Any doubts?
If you are having any doubts, students, you can type it in the chat box.
Or you can raise your hands.
Students are asking about h value.
H value. Okay.
Yeah.
H value is in general b minus a by n. B is the upper limit, a is the lower limit. Okay. And here integral a to b, a equal to 0 and b equal to 5. Therefore, h is equal to 5 minus 0 by n. Then it will be 5 by n. Clear?
Ma'am, one more question.
Hmm.
Is there any alternative way or any trick which can be applied to these kind of questions? Because maybe in competitive exams and all, these questions will be like objective type will be there.
Competitive exams, I can guarantee you they will not ask this type of questions because it is descriptive. Okay, so don't worry about it because we have many easy way to find definite integrals. Definitely, they will not ask evaluate definite integral using limit as a sum. That I can guarantee.
Okay. Is there any formula or we can use any formula to do this directly?
Is there any formula?
Huh.
Actually, we can find there are some tips. For example, see in this problem we have 2x, right? Or a term containing x, power of x is 1 here. And we got the sum like sigma I equal to 1 to n minus 1 I. And similarly, in the second problem also, there is presence of x power 1. X means x power 1. And here also we got the same sigma, right? Sigma I equal to 1 to n minus 1 I. So if x is there, I mean x alone, x power 1 is there, then normally that will connect us to this sigma I equal to 1 to n minus 1 I. The method is same. There is no shortcut up to my knowledge.
So I think Gokul and Jayashree has raised their hand. So if you have any questions, please try to type that in the chat box or. Okay, the question is clear. So everyone has told like it's clear. There are no doubts. Ma'am, we can move on to the next part, I think.
Okay. Integral 0 to 3, 2x square plus 3 dx. Starting with the formula. No need to explain. Integral a to b f of x dx. A is up lower bound, b is upper bound, b minus a, limit n tends to infinity, 1 by n, f of a plus f of a plus h plus f of a plus 2h plus etc. plus f of a plus n minus 1h. And lower limit is 0. So a equal to 0, upper limit is 3, b equal to 3. And h is always defined as b minus a by n. And applying the values 3 minus 0 by n. This is how we are obtaining the value of h 3 by n. Okay. Integral 0 to 3, 2x square plus 3 dx is 3 minus 0, limit n tends to infinity, 1 by n, f of 0 plus f of 0 plus h, that is f of h, f of 0 plus 2h, f of 2h plus etc. plus f of n minus 1h, 0 plus n minus 1h, so f of n minus 1h. We can find the values one by one. F of x is 2x square plus 3. Now we need f of 0. F of 0 is 2 into 0 plus 3, that is 3. Now we need f of h. F of h is 2h square plus 3. Now f of 2h. Two into x square, so 2h square plus 3, that will be 8h square plus 3. 2 into 4h square, that is 8h square plus 3. Now f of 3h, 2 into x square, so 3h the whole square plus 3, 18h square plus 3. And finally, f of n minus 1h, 2 into n minus 1 h the whole square, that is n minus 1 square h square plus 3. These are the values. Now we are going to substitute. And as I told you, if x is there, that will give us sigma I equal to 1 to n minus 1 I. Similarly, here we have x square. So it will take us to sum of squares of first n minus 1 natural numbers, x square. Integral 0 to 3, 2x square plus 3 dx is equal to 3 minus 0, 3, limit n tends to infinity, 1 by n. F of 0 is 3. Then f of h, 2h square plus 3. F of 2h, 8h square plus 3. F of 3h, 18h square plus 3 plus etc. plus last term 2 into n minus 1 square h square plus 3. As in the previous cases, we can collect the common terms. We can see that in each and every term, 3 is present. Then 3 plus 3 n times. What remains is 2h square plus 8h square plus 18h square plus etc. plus 2 into n minus 1 the whole square h square. 3 into limit n tends to infinity, 1 by n. This is 3n. Now, in these terms, we can see that 2h square is common. So 2h square, first term, if you are taking 2h square outside, it will be 1. Then second term, 8h square, it will be 4. I'm writing that as 2 square. And 18h square, we can take 2h square outside. It will be 9, that is 3 square. Similarly, the last term, 2 into n minus 1 the whole square h square. We can take 2h square outside. It will be n minus 1 the whole square. So 3 into limit n tends to infinity, 1 by n, 3n plus 2h square into 1 plus 2 square plus 3 square plus etc. plus n minus 1 the whole square. So sum of squares of first n minus 1 natural numbers. And we know that sum of squares of first n natural numbers, sigma I equal to 1 to n, I square is equal to n into n plus 1 into 2n plus 1 by 6. Okay. Here it is 3 into limit n tends to infinity, 1 by n, 3n plus 2h square into sigma I varies from 1 to n minus 1 I square. Because we have 1 to n minus 1 squares. Now, using this reduction formula, 3 into limit n tends to infinity, 1 by n, 3n plus 2h square into sigma n equal to sigma I equal to 1 to n minus 1 I square. In this equation, we need to replace n by n minus 1. So we can say that it will be n minus 1 into n into 2n minus 1 by 6. And h value is 3 by n. That's equal to 3 into limit n tends to infinity, 1 by n, 3n plus 2 into h square. I'm replacing h by 3 by n. So it will be 9 by n square. And n minus 1, I'm taking 1 n outside. So n into, then if I'm taking n from this n minus 1, it will be n into 1 minus 1 by n. Similarly, from this 2n minus 1, I'm taking n outside. It will be 2 minus 1 by n by 6. I repeat, 3 into limit n tends to infinity, 3n plus 2 into h square. H is equal to 3 by n. So h square will be 9 by n square. Then n. From this n minus 1, I'm taking n outside. Then it will be n into 1 minus 1 by n. Similarly, from 2n minus 1, I'm taking n outside. Then it will be n into 2 minus 1 by n. Again simplifying, this is equal to 3 into limit n tends to infinity, 1 by n, 3n plus 9 into 2, 18. 18 by 6, 3. So 3 into n square will get cancelled. What remains is 1 minus 1 by n into 2 minus 1 by n. 3 into limit n tends to infinity 1 by n, 3n plus 18 by 6, 3. N square will get cancelled. Then remaining factors are 1 minus 1 by n into 2 minus 1 by n equal to limit n tends to infinity. I'm multiplying this 1 by n inside. So it will be 3 plus this n and this n will get cancelled. So 3 plus 3 into 1 minus 1 by n into 2 minus 1 by n. Now we know how to compute the limits. 3 into limit n tends to infinity, 3 plus 3 into 1 minus 1 by n. Since n tends to infinity, 1 by n will tend to 0. 1 by n will tend to 0. So here what remains is 3 into 1 into 2. So 3 into limit n tends to infinity, 3 plus 3 into 1 into 2. So 3 into limit n tends to infinity, 3 plus 6, 9. Since 9 constant, there will not be any change in the value. 3 into 9, answer 27. Lakshmi ma'am?
Yes, ma'am. I'm just looking for the questions in the chat box. So there is one question like, ma'am, can you please explain f of a plus h, f of 2a plus h substitution, and how it is 18x raised to 2 in the third term?
Okay. F of a plus h. F of a plus h, f of a plus 2h. Here, a value is 0 because a is the lower bound. A represents the lower bound. A value is 0 here. Therefore, it will reduce to f of 0, then 0 plus h. That is f of h, 0 plus 2h. If a equal to 0, f of a equal to f of 0, right? Similarly, f of a plus h equal to f of 0 plus h equal to f of h. Am I right? 0 plus h is h, right? Similarly, what will be f of a plus 2h? F of a plus 2h is equal to f of 0 plus 2h, and 0 plus 2h is f of 2h. Yes. Now, coming to the values. F of x is 2x square plus 3. F of 0, in this f of x, we need to replace x square by 0. 0 square. 0 square is 0. So this term will vanish. It will be 2 into 0 plus 3, that is 3. Now f of h. F of x is 2x square plus 3. So if it is f of h, in this equation, we need to replace x by h. So x square will become h square. So 2h square plus 3. Now coming to f of 2h. F of 2h, f of x is 2x square plus 3. So this x should be replaced by 2h. So it will be 2h the whole square. So 2 into 2h the whole square plus 3. And 2h the whole square is 4h square. 4h square into 2 is 8h square plus 3. So 8h square plus 3. Now f of 3h. F of 3h is equal to f of x is 2x square plus 3. So what will be f of 3h? In the place of x, we have to write 3h. So it will be 2 into 3h the whole square. So 2 into 3h the whole square, and 3h the whole square is 9h square. So it will be 2 into 9h square plus 3, which is equal to 18h square plus 3. Is it clear now? Ma'am, can you please check?
Yes, ma'am. One more thing that one student have posted it. Can you please give an outlook on the indefinite also?
Indefinite. But today I think it's about to end.
Okay, okay.
No, it's
So that's
little-
completely fine. Maybe we can do it on another part.
Indefinite is without limits.
Ma'am, do you have more questions to discuss today, or is the portions over?
Ma'am, same type of problems, ma'am. That's all.
Okay, okay, okay.
So
Maybe I think we
I
can
can-
discuss one or two questions. It's like we have some more time.
okay. So any more doubt in these 3 problems? Otherwise, I'll move on to the next problem.
Yeah, we can move to the next problem, I think.
Okay, okay. Integral 1 to 4 x square minus x dx. And here itself, we can make the outline. X square is there, then definitely it will take us to sum of first n minus squares of first n minus 1 natural numbers. X is there, it will take us to sum of first n minus 1 natural numbers. So x square is there, it will take us to sum of squares of first n minus 1 natural numbers. If x is there, it will take us to sum of first n minus 1 natural numbers. And be clear about the values of a and b. A means the lower bound and b means the upper bound. Okay, so a equal to 1 and b equal to 4. This is the formula. A equal to 1, b equal to 4. H is b minus a by n. Upper bound 4, lower bound 1. So 4 minus 1 by n, that is 3 by n. Now coming to the integral. 1 to 4 x square minus x dx. B minus a, that is 4 minus 1. Limit n tends to infinity. And here a is not equal to 0. So there will be difference. A is equal to 1 here. So f of 1 plus, see this one, f of a plus h. F of a plus h, a is equal to 1. So it will be f of 1 plus h. We cannot simplify further. It will be f of a plus 1 plus h. Now f of a plus 2h. A is equal to 1. So it will be f of 1 plus 2h. Similarly, last term, f of a plus n minus 1h. A is equal to 1. So it will be f of 1 plus n minus 1h. So what will be the formula here? 4 minus 1, that is 3 into limit n tends to infinity, 1 by n, f of 1 plus h, f of 1 plus 2h, plus etc. plus f of 1 plus n minus 1h. In previous problems, upper bound, lower bound was 0. So we got it as f of 0 plus f of h plus f of 2h plus etc. plus f of n minus 1h. But here, the lower bound is 1. Therefore, it will be f of 1, a is equal to 1. So f of 1 plus f of 1 plus h plus f of 1 plus 2h plus etc. plus f of 1 plus n minus 1h. Now, we can find the values. F of x is x square minus x. F of 1, 1 minus 1, 0. X square, replace x by 1. So 1 square minus 1, that is 1 minus 1, 0. Now next term is f of 1 plus h. So f of 1 plus h is equal to, in this form, x square minus x. We have to replace x by 1 plus h. So what will be the formula? What will be the equation of, or what will be the value? 1 plus h the whole square minus of 1 plus h. Am I right? X should be replaced by 1 plus h. I repeat, f of x is equal to x square minus x. And if you want to find f of 1 plus h, then in the place of x, we have to write 1 plus h. Here it will be 1 plus h the whole square minus 1 plus h. Expanding this, 1 plus h the whole square, 1 plus 2h plus h square, minus 1 minus h. 1 plus 2h plus h square, minus 1 minus h. 1 minus 1, 0. 2h minus h, h plus h square. So f of 1 plus h is equal to h plus h square. Now, next term, f of 1 plus 2h is equal to, in this form, x square minus x, you replace x by 1 plus 2h. So it will be 1 plus 2h the whole square minus 1 plus 2h. Okay. 1 plus 2h the whole square minus 1 plus 2h, expanding 1 plus 4h plus 4h square minus 1 minus 2h. 1 minus 1, 0. 4h minus 2h, 2h plus 4h square. So 2h plus 2h the whole square. Similarly, proceeding like this, we can show that 1 plus 3h is equal to 3h plus 3h the whole square. And finally, f of 1 plus n minus 1h is equal to n minus 1h plus n minus 1h the whole square. Okay. Now coming to the integral. Integral 1 to 4 x square minus x dx equal to b minus a is 3, 4 minus 1. So 3 into limit n tends to infinity, 1 by n. F of 1 is 0, 0 plus f of 1 plus h plus h square, plus f of 1 plus 2h, 2h plus 2h the whole square, plus f of 1 plus 3h, 3h plus 3h the whole square. And the final term will be n minus 1h plus n minus 1h the whole square. You are simply substituting the values. So 3 into limit n tends to infinity, 1 by n. And we have terms of h and h square. I'm grouping terms of h and terms of h square. So first term 0, leave it. H plus 2h plus 3h plus etc. plus n minus 1h. So h plus 2h plus 3h plus etc. plus n minus 1h. Next group, h square, 2h the whole square, that is 4h square, 3h the whole square, 9h square. Last will be n minus 1h the whole square. So it will be h square plus 2h the whole square plus 3h the whole square plus etc. plus n minus 1 the whole square h square. How we can simplify? Taking the common factors. 3 into limit n tends to infinity, 1 by n. In all these terms, h is common. So from these terms, I'm taking h outside. So h into 1 plus 2 plus 3 plus etc. plus n minus 1. First group. Now coming to the second one, h square is common. So I'm taking h square outside. So h square into 1 plus, if I'm taking 2 h square outside, it will be 4. 4 is 2 square. Now h 3h the whole square, we are taking h square outside, it will be 3 square plus etc. plus n minus 1 the whole square. Okay. Now first group, we can see that sum of first n minus 1 natural numbers. Second group, sum of squares of first n minus 1 natural numbers. So limit equal to 3 times limit n tends to infinity, 1 by n, h into sigma I equal to 1 to n minus 1 I plus h square into sigma I equal to 1 to n minus 1 I square. equal to, substituting the values for this sigma, 3 into limit n tends to infinity 1 by n, h into this sigma is n minus 1 into n by 2 that we discussed, h square into sigma I varies from 1 to n minus 1, I square will be n minus 1 into n into 2n minus 1 by 6 using these identities. And what is h value? H is equal to 3 by n, 4 minus 1 by n, that is 3 by n. Now in this, we are going to replace h by 3 by n. So limit 3 into limit n tends to infinity 1 by n, h is 3 by n. So instead of h, I'm writing 3 by n into n minus 1 by n by 2 plus h square. H square is 3 by n the whole square. So it will be 9 by n square into sigma value is n minus 1 into n into 2n minus 1 by 6. Now just simplification. 3 into limit n tends to infinity 1 by n. N will get cancelled. What remains is 3 by 2 into n minus 1. Here n and n will get cancelled. So 3 by 2 into n minus 1 plus 9 by 6, 3 by 2. So 3 by 2 n square. And among these factors, I'm taking n outside. So if I'm taking n from n minus 1, it will be n into 1 minus 1 by n, then n. Similarly, n into 2 minus 1 by n. So I repeat, 9 by n square, n minus 1, n into 2n minus 1 by 6. 9 by 6 is 3 by 2, then n square. Each factors we are taking n outside. So from n minus 1, we are taking n. It will be 1 minus 1 by n into n. Then n is there. 2n minus 1, that will be n into 2 minus 1 by n. So this is equal to limit n 3 times limit n tends to infinity 1 by n, 3 by 2 into n minus 1 plus 3 by 2n square n into 1 minus 1 by n into 2 minus 1 by n equal to 3 into limit n tends to infinity 1 by n. And from this n also, n minus 1 also, I'm taking 1 n outside. So it will be 3 by 2 into n into 1 minus 1 by n plus n square n will get cancelled. 3 by 2. What remains is 1 minus 1 by n. And here we have n cube, 1, 2, 3. So n cube. So 1 n will remain there. 1 minus 1 by n into 2 minus 1 by n. Three into limit n tends to infinity. Inside the brackets, we have 1 by n. And if you are multiplying this 1 by n with this n, they'll get cancelled. So what remains is 3 by 2 into 1 minus 1 by n plus 3 by 2 into 1 minus 1 by n into 2 minus 1 by n. These two n will get cancelled with this 1 by n. This n and this n with this 1 by n. So finally, it will be 3 into limit n tends to infinity. If you are applying limit, n tends to infinity, so 1 by n, 0. So it will be simply 3 by 2 plus 3 by 2 into 1 by n, 0. So 1. Then 2 minus 1 by n, 1 by n, 0. So 2. So 3 by 2 into 1 into 2. 3 into 3 by 2 plus 2 will get cancelled. What remains is 3. So 3 into 9 by 2, answer 27 by 2. Lakshmi ma'am?
Ma'am, actually there is one question in the chat box. Can you please explain the 1 plus h expanding part?
Which one, ma'am? 1 plus?
H expanding part. I think maybe this section.
This one?
Yes, I think so.
Okay. This is the actual doubt?
Yes, ma'am.
Okay. see, what is f of x? F of x is x square minus x. So what will be f of 1 plus h? In the place of x, we have 1 plus h. This x should be replaced by 1 plus h. So x square will be 1 plus h the whole square. Then minus x. X should be replaced by 1 plus h. So it will be 1 plus h the whole square minus 1 plus h. Now we are expanding this 1 plus h the whole square. What is 1 plus h the whole square? 1 plus 2h plus h square. Then minus 1. This minus is common for 1 and h. So minus 1 minus h. 1 and minus 1 will get cancelled. Then 2h minus h is h. Then plus h square. So it is h plus h square. Is it clear now?
Ma'am, actually one student is asking permission to speak. Actually, it's Gokul Raj. Can I allow him to speak?
Yes.
Okay, okay. Yeah, I have given you permission, Gokul. You can speak right now. Please try to unmute yourself and you can speak.
Good evening, ma'am.
Good evening, Gokul.
Ma'am, I have doubt regarding instead of using the definite integral formula, can we integrate that function and applying the can we do like
Gokul, your audio is feeble.
ma'am? Now it is audible, I think.
Yeah,
Yes,
it's fine.
Gokul, ask me.
Ma'am, instead of using the definite integral formula, can we integrate the function directly and applying the final limit minus initial limit? So can we
Gokul, no one is interested in this lengthy step. But sometimes in the question paper, they'll specify the method for descriptive type questions. Okay. So if you are asked to evaluate this integral using limit as a sum, then you cannot use the direct one. Got it? Even though your answer is correct, any marks will be awarded to you.
Okay, ma'am. Whether this integral formula is applicable for all the type of functions?
Which one?
The given integral formula.
Definite integral formula is applicable to, you mean direct integration?
Yes, ma'am.
Direct integration is applicable to all functions. Only thing that function, we have to bring that function to the integrable form. Suppose we have a function like this, root of 1 plus x raised to 4. It's a little bit difficult to integrate, right?
Yes, ma'am.
But being +2 students, they will not ask you much difficult questions. So in those type of problems, this method may help us.
Yeah.
But if the method is not specified in the question paper, you can choose your own method. There is no such restriction. But if it is specified, then if you are using another method, you will not get marks. That's all, even though the answer is correct. Okay.
Then another doubt I have, that is in the integral, definite integral formula, in the last part, you put n minus 1 the whole bar. Why you put that bar?
Can you repeat, please? I couldn't hear.
Ma'am, in the definite integral formula, in the last part, you put n minus 1 the whole bar into h. Why you put that bar? What is the reason?
Actually, this is not a random formula. We have derivation for this. Since we don't have time, I didn't explain that part. In the textbook, you can see they have divided the region into so many rectangles, and they are collecting the area of the rectangles, and some areas may get cancelled. Okay, in that way, we are obtaining this formula.
Okay, ma'am.
Okay, for exam, that theory part is not needed. That's why I didn't explain.
Okay, ma'am.
Okay.
So students, if you have any other questions, you can just type it in the chat box. Our ma'am will be addressing those questions. So I think the questions are okay. So students are having Do you have any doubts? So I think, ma'am, everything is clear. It's already
Only thing is,
7:10.
yes, the only
Yeah,
thing
yeah,
is the method is lengthy, so they need shortcut. But what to do if this method, there's no shortcut. 2-3 tips I can give you, that's all. X square means we'll be getting, it will take us to sum of squares of natural numbers. X is there, it will take us to sum of first n minus 1 natural numbers. That's all. There is no other shortcut up to my knowledge. And for entrance examination, definitely they will not ask you to evaluate definite integrals using limit as a sum. Anything else?
No, ma'am, there are no questions in the chat box.
Okay.
Yeah,
Okay.
one more student is asking permission to speak.
Yes, ma'am.
Okay, just give me a minute. I'll allow you to speak. Yeah, I have given you permission. Please unmute and try to speak right now.
Good evening, ma'am. Can you hear me?
Good. Yes. Good evening. Your name, please?
My name is Ritesh, ma'am.
Ritesh. Yeah, tell me, Ritesh.
What I'm asking is, instead of using this long method, can we do simpler, like if a question is given, integrate that question separately, and then apply upper limit minus lower limit, means will not be derived to the answer?
Just now I have answered to the same question. Someone else asked, Ritesh, the problem is if the method is specified, you are adopting another method, then you will not be awarded marks, even though the answer is correct.
Okay, so if there is no restriction, we can use this method.
Yes, that's your choice. Even myself will not prefer this method because it's very lengthy. But
Yes.
if I'm forced to do by this method, then there is no other way. That's all. Okay.
Okay, ma'am.
Right.
Thank you.
Anything else? Any other queries?
No, ma'am. So students, for the last time, if you have any questions or if you, okay, if you have any questions, you can just type in the chat box. Okay. Ma'am, students are asking about the name of this method.
Name of this method. This method's name is definite integrals as the limit of sum. So if you are asked to evaluate definite integrals as the limit of a sum, you have to follow this method. See, this is the sum. F of a plus h plus f of a plus 2h plus etc. plus f of a plus n minus 1h. Limit n tends to infinity 1 by n into this sum. So we are taking limit of this sum divided by n as n tends to infinity. That's why limit of a sum and getting the value. And the question paper, it is specified, you have to follow this method.
Ma'am, one more question from students is, what is the name? Sorry. Just give me a second.
Can you please explain?
About fractions also. Yeah, about fractions also students are asking.
Fractions.
How to solve this?
Fraction, I didn't get.
Oh, just give me a minute. I'm checking for the question. I'll just read it out.
Ma'am, the question is, can you please explain one sum with limits in fraction?
Limits in fraction.
Yes.
Okay, let's try. I'll take a simple function. See, for convenience, for reason is I'm taking the lower bound as 0 and upper bound as 1/2. Okay. Oh, if it is 0, then fraction will not occur. Okay, okay. I'm taking this as 1/2. Then to 1. Lower bound, upper bound as 1. Then x dx. Okay. Let me copy paste something. Yeah. Okay, don't worry about these numbers. So A equal to 1/2. B equal to 1. And H will be 1 minus 1/2. I'm just writing that as 0.5. So 0.5 by yeah. Or 1/2. Okay. Now this is equal to 1/2 then 1 1/2 1 minus 1/2 is 0.5 0.5 limit 10 tends to infinity and f of 0 instead of 0 we need to write 1/2 because A is equal to 1/2 here. Then 1/2 plus H 1/2 plus 2H etc. 1/2 plus n minus 1 into H. Okay. Then 0.5 into this one. There is no simplification for this because A is not equal to 0. It's 1/2. Now f of x is equal to x. And instead of f of 0, we need to find f of 1/2. And what is f of 1/2? Since f of x is equal to x, f of 1/2 is 1/2 itself, right? F of 1/2 is 1/2. Now we need f of 1/2 plus h. F of 1/2 plus h equal to f of x is equal to x. And here in the place of x, we have 1/2 plus h. So we have to write it as 1/2 plus h. Since replace x by 1/2 plus h. Now f of 1/2 plus 2h. F of x is equal to x. Now f of 1/2 plus 2h means x should be replaced by 1/2 plus 2h. So it will be 1/2 plus 2h. Similarly, f of 1/2 plus 3h, everything we can find. And what will be the final term? F of 1/2 plus n minus 1 h. X should be replaced by 1 by 2 plus n minus 1 h. These are the values. Now coming to this part, this is equal to, I'm substituting the values, 0.5 into limit f of 1 by 2. F of 1 by 2 is 1 by 2. So 1 by 2 plus f of 1 by 2 plus h. And we have seen that f of 1 by 2 plus h is 1 by 2 plus h itself. So that will be 1 by 2 plus h. F of 1 by 2 plus has to be replaced by 1 by 2 plus h. Similarly, f of 1 by 2 plus 2h is 1 by 2 plus 2h, etc. And finally, f of 1 by 2 plus n minus 1 h is equal to 1 by 2 plus n minus 1 h. Now you group the terms. 1 by 2 is common in all the terms. So 1 by 2, 1 by 2, 1 by 2, n times. It will be n into 1 by 2 or n by 2. So equal to n into 1 by 2 that is n by 2. Then what remains is h plus 2h plus 3h plus etc. plus n minus 1h. So this is equal to n by 2. See, h is common for all these terms. So I'm taking h outside. So it will be h into 1 plus 2 plus 3 plus etc. plus n minus 1. One plus 2 plus 3 plus etc. plus n minus 1. Rest you can complete. Is it okay? Lakshmi ma'am?
Yes, ma'am. So I think it's completely fine. And yes, ma'am. I think students have understood the question, so it's completely fine. So it's already 7:25, so I think we'll stop our session today.
Okay, okay.
So thank you, student, and
I'll stop sharing.
yeah, you can stop sharing, ma'am.
Okay.
And I hope, students, this was really wonderful session, and so many problems were solved during the session. So if you have any doubts also, you can contact Amrita team. We'll be really happy to help you all. And thank you, Sreeranjini ma'am, for this wonderful part. So thank you so much. Thank you, students. We can see tomorrow with another physics session.